Hello there and welcome to the June 2018 paper. Here we're on question 9. So this is the function g of x. Use the factor theorem to show that x plus 2 is a factor of g of x. So to use the factor theorem at this point here, we need to plug in the value minus 2 into, not the f function, the g function. So g of minus 2 equals 4 of minus 2 cubed minus 12 times minus 2 squared minus 15 times minus 2, add 50. It's a good idea at this point just to do the individual calculations. So this will be minus 8 times 4 is minus 32. This will be 4, so that will be minus 48. This will be plus 30, and this will be plus 50, which is clearly equal to 0. Now we need to do a little conclusion. As g of minus 2 equals 0, by the factor theorem, and you've got to use the word factor theorem there, by the factor theorem, x plus 2 is a factor of g of x. Okay, please make sure you definitely put that conclusion in. That's worth 1 of the marks out of the 2. So part B, hence show that g of x can be written in the form x plus 2 and then this expression here where they are integers to be found. So we need to do some algebraic division here. So 4x cubed minus 12x squared minus 15x plus 50 is going to equal x plus 2. Now let's work out what needs to go inside the bracket. So it's definitely going to have to be a 4x squared as the first thing inside the bracket to make ourselves the 4x cubed. Now when we expand that, we're going to get 4x cubed and then plus 8x squared. But we actually would like minus 12x squared when it's all fully expanded, so I now need to take away 20x squared. So in the second position here, we'll need to times by x to give us this minus 20x squared, so that's going to be minus 20x. So now when I expand that with the 2, I'm going to get minus 40x. But I don't want minus 40x, I want minus 35. So I'm going to have to now add 25x. So I'm going to need to put an add 25 here, and that will then expand with the 2 to give me a plus 50. So there we are. That's the factorized version of the left-hand side. And then if I factorize it a little bit more, just by a bit of trial and error, it's going to be 2x minus 5. 2x minus 5. So therefore it's going to be x plus 2, 2x minus 5 squared. So therefore a equals 2, b equals minus 5. So there we are, that's the answer for part B. Let's now move on to part C. So the g of x function, actually no, we don't really need it. Use your answer to part B and the sketch to deduce the values for x for which the g of x function is less than or equal to 0. So if I remember rightly, that's the minus 2 value. This is 5 over 2. So for part I, when does the g of x function go below 0 or equal to 0? Well, it's going to be for x is less than or equal to minus 2, and the specific point of x equals 5 over 2, because that's when it is equal to 0 as well. Because this is less than or equal to 0, it's this point, is this value here, where it's going to be less than or equal to 0. But also this point here that will be exactly equal to 0. Moving on to part II, g of 2x that will equal 0. So if we think about squishing the graph in by a factor of 2, it's going to be when x equals minus 1, that will be the point of equaling 0, and and 5 over 4 will also be a point where if we squish it in by a factor of 2, because if we think of this as a graph transformation, then it's going to be squishing it inwards by a factor of, well, it's going to be squishing it by a factor of a half. So minus 2 will go to minus 1, and 5 over 2 will go to 5 over 4. So these will be the points where the function will equal 0. And there we are, that's the answer for this question here then. That's question 9 marks for that one. Let's now move on to question 10.